Hello coders, welcome to the channel. This is the first video of the channel. In this channel, we will be discussing about the coding problems across all the platforms that are present, which are interesting. Today, we'll be discussing about the daily challenge 1437 of LeetCode. The usual flow of the problem solving would be as if we are solving this in an interview, where first we'll be looking at the brute force solution, and then we'll be looking at the optimized ones, and then we'll reach the most optimized solution. So the question is, check if all ones are at least length k places away. So it says there's a binary array of nums with an integer k. Return true if all ones are at least k places away from each other, otherwise return false. Which means the question is quite simple, that we need to basically check the number of indices between two neighboring ones. If it's greater than or equal to k in all the places, then we have to return true, otherwise we have to return false. As the examples given here, the number of indices present between two neighboring ones are 3. Since the k is 2, this satisfies. Now if we look at this 1 and 1, there are two zeros in between. Since the k is 2, it should be at least k places, so this is also works. If the neighboring condition works, then the transitive relation automatically works. If this works, let's say A, B, C are there. If A, B works and B, C works, A, C automatically works. Now we'll be looking at the brute force solution. In the brute force solution, what we will be doing is basically we will be storing the indices of ones in a vector. We'll name this as 1. Pardon me for this namings. We'll be running a loop, and what we would be doing basically is to store these indices of 1 in this vector, and we'll be checking the neighboring indices if the distance between these two indices is greater than or equal to k or not. If it's not, we have to return this false right away. If it's yes, we need to look for the other indices as well. We computed the indices array. We have to be careful here. We should not be keeping n because we need to loop over the indices. And what we will be doing here is checking the neighboring ones. If it's less than k, we will return false straight away because we have faced a wrong combination. Also return true. So here the reason why I do -1 is because we should not be considering the two ones. We should only consider the in between places, number of places that are in between two ones. That should be at least k. So let's run this. Yeah, let's submit this. Yeah, as we can see that it's submitted, but so the time complexity here is O of n, and the space complexity is also O of n because we've used a vector. Now here we cannot optimize on the time complexity, but we can definitely optimize on memory. Instead of using a vector here, since we are actually computing the neighboring ones, instead of vector, if we can just have the last one, index of last one, that would be sufficient. We don't need to completely have the array. So let's keep it like this. And let's loop over the nums. If nums of I is 1, if the last index is -1, which means this is the first one that we've encountered, so we are going to store that index. If not, we will be doing if current index minus last index minus 1, if it's less than k, we need to return false, and then mark last index as I. This way, this is the same logic that we did in the brute force, but here instead of using an array which is taking a O of n memory space, we are just using a variable. Now this O of n time complexity with O of 1 space complexity. Let's submit this and see. Yep, great. So this is how we solve this question. If you have any doubts and queries, please drop a comment. I'll try to respond to you guys as soon as possible. And thank you so much for watching this video till the end. For more such videos and content, please subscribe to this channel, hit the like button. Bye guys.